Our background, and we are about to start our review of classical laminate plate theory. Are there any questions on so far on history of composites as presented by me? It's not necessarily the correct version, it's one of the versions. All right, let's meet in 15 minutes. And for some reason, I'm convinced there's more than 15 people in this room. So any of you who haven't signed up and intend to so what's wrong with you people? Like after the 15th person, you said, okay, screw the others, let's have this. So please pass it around again and complete the list. Okay, so classical laminated plate theory is the theory that was developed in the 60s, or was mostly developed in the 60s. And a lot of people, the people working at the Air Force Materials Laboratory, which was the center of the best research at the time for composites and for quite a few other things, were involved in this. It's basically one way of representing plates whose properties are not the same in different directions. So I'll be going quickly through this in the next 45 minutes. Airplane structures or any flying structures have at least one dimension that's very small compared to the others, like we have plates and shells that represent the fuselages and so on. So usually we have plane stress conditions, so under certain circumstances we may have plane strain, and then we can go into the three-dimensional, and for isotropic materials we have the isotropic elasticity. Now there are complete parallels to these for composites. The big difference is that this is an anisotropic elasticity, which complicates things quite a lot, especially when you try to solve problems in general.